Hello everybody. Okay, so in this video we are looking at difference equations, and later on in the video we're going to be looking at how to solve a first order difference equation. So before we get into a difference equation, we just need to learn about a recurrence relation, because that is the fundamental idea behind a difference equation. So a recurrence relation is a formula that defines each term of a sequence using one or more previous terms. So for example, to get the next term, you times the previous term by 2. Or to get the next term, you times the previous term by 2 and add 5. You know, stuff like that. So example of a recurrence relation is this one. Tn is equal to Tn minus 1 plus 3. So to get the next term, right, you have to add 3 to the previous term, Tn minus 1. So the previous term, you add 3. So we use this for a difference equation. What is a difference equation? So a difference equation is a mathematical rule that defines each term of a sequence, and it's based on one or more previous terms. So it's essentially a recurrence relation. So unlike differential equations, which is something you study in calculus in a later chapter, differential equations is the study of continuous change, while the study of difference equations is more about discrete change. You know, the change that happens on a day-by-day basis or month-by-month basis, etc., etc. So when we are asked to solve a difference equation, right, what we're just being asked to do is we're being asked to change this recurrence relation here into a function of n. So it would be like 3n plus 6. You know, that is what we're asked to do there, where n is the term number. So difference equations are used to model a lot of things. They are used like in economics to model interest rates, investments, and economic growth. It's used in biology to study population dynamics and the spread of diseases. And in finance to forecast stock prices and market trends. So they are particularly useful when data collected is at discrete intervals such as daily, monthly, or yearly investment. So let's have a look at first order difference equations. So a first order difference equation is a recurrence relation in which each term depends only on the immediately preceding term. So it's only based on the previous term. So for example, Tn plus 1 equals 5Tn minus 2. So to get the next term, we add 5 to the previous term. We times the previous term by 5 and subtract 2. Over here, Tn plus 1 is equal to 1/3 Tn plus 3, right? We multiply the previous term by a third and add 3 to it. So how to solve a first order difference equation. You calculate the first few terms in your recurrence relation. You calculate T1, T2, T3, etc. And you keep them in expanded form. So you'll see what I mean now in a minute, right? So you don't multiply out any brackets you have. And it makes it easier to recognize patterns. And finally, you identify any geometric series that appear, and you simplify them using the finite geometric sum formula. So let's have a look here. Solve the following difference equation. So I have un equals a half un minus 1 plus 3, where u0, my initial term, is 144. So solve the difference equation. So like I said, right? We need to write out the first few terms. So I have u0 equal to 144. That's fine. That's easy. What about u1? How do I get u1? How do we get the next term? Well, if we look at my recurrence relation, here, it's a half the previous term plus 3. So it would be a half times 144 plus 3. This is known as expanded form, right? So don't multiply that out. U2 is going to be half of the previous term, a half of the previous term, and the previous term being a half times 144 plus 3. And then finally, we add 3. Multiply that out, I get a half squared times 144 plus a half times 3 plus 3. U3, my next term after this, is going to be half my previous term. So it's half all of this. So it's going to be a half times a half squared 144 plus a half times 3 plus 3. And then I add 3 on the outside. So U3 is going to be 1 half cubed times 144 plus 1 half squared times 3 plus a half times 3 plus 3. And we are starting to notice a pattern here. What we're noticing here is the power of this number is always going to be my term number in my recurrence relation. And then if I reorder this here, this is going to be 3 plus a half times 3 plus a half squared times 3. So if I'm solving for un, I know it's going to be a half n times 144 plus 3 times a half times 3 plus a half squared times 3. And this is going to go dot, dot, dot. This is going to go on forever up until a half n minus 1 times 3. Because what you notice here is the highest power on this side is always going to be 1 less than my term number. So this here is a geometric sequence. So a geometric sequence, remember, is just to get the next term, you multiply by something. So in this case, I'm multiplying by a half. And the sum of a geometric sequence is given by Sn equals a times 1 minus or to the n all over 1 minus or. Where or is my common ratio, i.e. what I'm multiplying by. That's going to be a half. A is my first term, which is 3, and then n is just going to be n. So this can all be written as 3 times 1 minus a half the n all over 1 minus a half, which is going to be equal to 3 times 1 minus a half to the power of n all over a half. 3 divided by a half is 6. So I'm left with 6 times 1 minus a half to the n. And I have over here now a half n times 144. Right, now let's gather up my half to the power of n's. I'm going to be left with here a half to the power of n times 144 plus 6 minus 6 times a half to the power of n. Gather up my half power of n's. 144 minus 6 is going to be 138 times a half to the power of n plus 6. And that is how I solve a difference equation. I've now made it a formula or a function of n. And it's the same for any first order difference equation. Now, it asks me in part 2, find the steady state, i.e. when the limit of my sequence goes to infinity. So a steady state just means after a while, what value does my difference equation tend towards, right? So it might tend towards, if we're looking at population of a species, it might balance out at a certain amount. Or like we're doing savings, like no matter how much I save, it might flatten out to like the max I can only ever save really is like like 20,000 or something. Yeah? So the limit as n goes to infinity, i.e. the steady state, n goes to infinity, so it'll be 138 times a half to the infinity plus 6. A half to the infinity, but that's a half times a half times a half times a half times a half. This is going to tend to 0. So sorry, it's the limit. N goes to infinity. This is going to tend to 0. So 138 times 0 is 0. So my answer is just going to be 6. So the steady state of this first order difference equation is going to be 6. And that is how we solve a first order difference equation. I hope this video was some help to you guys, and I'll catch you guys later in the next video. Bye.